Yeah. So Kalavdi, like, so you have that machine with you. So is the Jenkins, is everything there?
Yeah.
1 second. Let me just give you. See if you can do a quick screen share. We'll just check it out.
Okay. Are you able to see my screen, right?
Yeah, I can see. Yeah. Okay, can you go to the configuration area?
Yeah.
Good, right?
Sorry, I didn't get you.
No, the connectivity to the server is.
Yeah. Good. If you want me to recheck, I'll. So everything is fine.
Okay. Okay. The configuration.
Yeah, it's fine.
Scroll down. Can you just scroll down further?
Yeah.
Okay. Can you just give the space after Ansible icon Playbook?
Space you want.
Yeah. So the file is copying to the destination, right?
Yes, it's copying.
So this second one, I think, the space can be one issue. Just try to do a quick check by saving.
Okay. Yeah, same error.
Exception when publishing inbuilt artifacts or SSH change. Okay, but you're saying that the file is copied there. Can you just go to the destination and see that file is copied?
You're asking about Tomcat or Ansible?
Ansible.
It's copied actually. You're able to see that?
Yeah. Can you run that playbook manually here?
Yeah,
Ansible
sure.
icon playbook.
The playbook is in different. Done.
The file is copied, right?
Yeah. Is there issue with plugin?
No, I think PWD. Can you do that? So you given the same path, right? It is
Yeah, given the same.
So yeah, can you go to the configuration once again? So you're trying to copy to the /opt docker. You removed the web app entire target directory, right? After copying that.
Okay. Do I want me to remove this?
No, that is fine. I mean, so what you're trying to do is that you're trying to copy start that war there.
Yeah.
I think it is copying, right? Anyway, so it is under /opt docker only, no?
Yeah, correct. It's copied.
Yeah. So you're actually removing the web app target. So up to here it is fine. Now just go to the second section, that is executing the playbook section. So this is where it is actually
Do you want me to show the playbook?
yeah. The playbook it is manually working, no? But still, yeah.
Yeah, it's fine. It's working fine.
Just do that one. I can edit that. /opt docker. The destination is /opt apache Tomcat. Okay.
Yeah.
So in the Jenkins configuration, what you can do, the second section, instead of running /etc, I mean that stuff.
Okay.
Do one thing: cd space /etc ansible and put a semicolon and give a space and then run the playbook command.
Okay. You're asking me to in execution command.
Yeah.
Okay.
To cd space /etc ansible.
Okay. Path do I need to give?
Yeah.
Okay.
Put a semicolon.
Okay.
No semicolon. I think not
Okay.
colon. And then put a space and then yeah. Now remove this /etc ansible in the ansible playbook command.
Okay. Is it fine?
Yeah. Try this out.
Or some.
Okay. Proceed. This must be JavaScript. Not sure. Just refresh the page. Okay.
Yeah, see.
Logs actually not even in detail. Description when publishing, exception message. See, build step. Send build artifacts or SSL.
Okay, Raghu, you can continue the class. Once done with the class, I'll check with you.
Yeah, I think you just with that particular set. So try to remove that second entry once again. And also that slash web app target one is there, right? So that is
Okay.
also, I mean, there should not be a showstopper, but just see, try with different folder and then try to update the playbook once again with the exact
Okay.
path and then try
Okay.
that option.
Okay. Thank you.
Yeah, thank you. Okay, so we'll start with Docker tray containerization. So Docker. So today's the agenda for this is try to discuss about containers versus virtual machines, and then we'll try to discuss the overview and the terminology of the Docker platform, just engine, images, containers, registry, repositories, and then we'll try to talk about Docker Hub and then orchestration tools. And then so we'll move on to introduction to the images and start with some containers. So what is a Docker? It's a platform for developing, shipping, running applications using container virtualization technology, which consists of multiple products and tools inside that. So one is the Docker engine, Docker Hub, and the machine, Docker Swarm, Docker Compose, and then the GUI tool Kitematic. So let's start with late 90s or early 2000, wherein one application will be on one physical server. Why I said like dark ages, that domain. So yeah, even in the industry, 20 years ago, means it's dark ages, right? So now here, the problem with this is that because of these physical machines, deployment times are very slow comparatively, and the cost involved in buying and maintaining a hardware and depreciation cost, and also there was a survey conducted by IBM, I guess, in 2004 or 5, and surprisingly, it came with the result saying that across the globe in all the data centers, close to 75% of the hardware was sitting idle. So all the corporate companies, they actually procured this hardware, keeping in view the forecast of the future utilization increase of the applications and etc. So wastage of resources. And in case if I want to scale up my environment, because it is physical machines, very difficult to scale. So you need space, power, you need network to be laid on, and there is a ample amount of time required by the data center engineers to procure and provision the machines to scale it up. Also, in case if I want to migrate from one data center to other center, it's a huge, gigantic process. So the machines has to be shipped from one data center to the other data center. Also, if any of the server, due to some physical issues, if it goes down, so they're all vendor dependent, so locked in. Let's say if you have an IBM Xeon server, so IBM engineer has to come and then replace the part. So this is a huge challenging from the data center maintenance part and all this stuff. So history taught and industry learned from that. So the hypervisor based virtualization was evolved. Now what is exactly this? Now this, on the top of this physical machine on the operating system, one software called hypervisor is to install. On top of this, each application now can run multiple virtual machines. So 2006, I guess, so that is when the VMware really changed the utilization of the hardware and all this stuff. Now people stopped, buying the hardware, corporates, because now they started increasing the utilization capacity of the machines by going with the hypervisor ESX servers. So results, better resource pooling now. One physical machine can divide into multiple machines, easier to scale. Yeah, so if you need, let's say 10 machines, each virtual machine, just scale it up and then provide to you. And then they started going onto cloud. So some companies started services. They have their own data centers, virtual machines to install. And let me know how many VMs you need, we will provide you. So rapid elasticity, pay as you go model. Amazon, Azure, Google Cloud. So these are the things, few cloud companies which came into the existence because of this revolutionary thing happened in the engineering, particularly the hardware section. But what are the limitations with these virtual machines? Now, even though you try to scale up the environment by installing multiple VMs, your VM still required some allocation and from the CPU memory storage point of view. Let's say that you have single machine, you have 3 virtual machines. In each VM, OS has to be installed. So we call it like guest OS. So the more VM you run, the more resources you need. And also because of this guest OS, so all these resources are wastage because you have multiple operating systems running inside those multiple virtual machines on the same hardware machine. And let's say that you migrate one application from one VM to another VM. There is no guarantee that even though it is on the same hardware machine, or and then the VMs are running in the same machine, so the same OS, we cannot guarantee that it will work on the other VM. Portability is not there. So these are the limitations with the virtual machines. So that is exactly when containers are introduced. So all this container-based virtualization uses what they do is they don't have operating system. They use the same kernel on the same host operating system to run these multiple virtual instances, or whatever you want to call it as guest instances, etc. Here, each guest instance instead of VM, we started calling it as container. Now this container will have what? Again, this is also will have the same its own root file system, memory, process, devices, network ports, like your VM, but you don't have OS this thing. So OS is the same OS which is deployed on the hardware machine, which will be shared by the container. So the advantage of this thing is now you can spin up more containers. Because you have a lot of resources availability and you don't need to have multiple operating systems. Also, if I migrate this particular container from one machine to another machine, where you have host OS and kernel and this kind of stuff, I can guarantee you that the application will work because this container contains the application and all the required components to run this application in isolated platform or isolated environment. It can be a Python, it can be a Java one, it can be an AngularJS one. So that is immaterial. This application requires, contains all those required components required to run this application in isolated environment. So I'll be sharing the same OS. So now it is more lightweight comparatively your VM. So containers are now more lightweight. OS is not needed. So they need now less resources. So that's like CPU, RAM. So now you can run more containers. Yes, portability is there. So Docker is one of the company. It is not only the company who developed this container acceleration, and it is not the first one. In fact, this was there in Sun Solaris in 2003 and 2 only with a concept called Jones. Yeah, so in 2003, the Jones concept was there. So I'm not sure if you got a chance to work on that. I mean, yeah, I was there in 2001. I mean, so so Jones, of course, later did not actually received by the industry because virtualization, VM, and all these things really shadowed this stuff. And later, the story Sun Solaris, what is acquired by Oracle, and then they did not continue that stuff. In the process, Vagrant came open source container kind of virtual technologies, but all these are like little heavyweight. So then Docker came into the existence, I guess, in 2014, I guess. So container, so it's very new. So close to how many years? 6 to 7 years. So now what they've done is the same stuff. Like they created a program called Docker Engine, which will be installed on top of your machine, Linux or OS machine. So what it will do, it will use some kernel features called namespaces and control groups to isolate the components which is running here to run in a separate memory there. On top of this, containers used to run. Now, if I go to another machine where Docker engine is running, my container will talk to the Docker engine, and container is not bothered about what kind of OS it is and where it is running, because container know how to talk to engine. It is engine's responsibility to talk to different flavors. Initially, it is only for the Linux flavors, all different flavors. Ubuntu, CentOS, Fedora, etc., RHEL, all the stuff. 2019 May is when Docker announced, when Microsoft announced that they're also supporting Docker, and it is an open source, as anyone can use it, etc. So here in Docker, we'll be seeing some terminology called images. So images are like similar to your, let's say in your cloud, you're spinning up an image, right? An AMI. It is the same stuff. So using one AMI, you can spin up multiple EC2 machines. Similarly, these images which are built by the vendor or by yourself will be there, read-only templates basically. And you can spin up the containers using that. Containers are like your EC2 machines. In a layman language, I'm saying. So Docker space images, this command is just a command which will actually refer the local repository on your machine to display, list all your images there in your local machine. Now, where these images will be residing. So Docker manages a central repository called Hub, Docker Hub, from where you can pull images and all the vendors can store their images also there. We'll do that in a one practical before we proceed anything like that. But let's try to understand a little architecture about this stuff. So the Docker runs on client server architecture. Here the client takes the CLI takes the inputs. So for example, in your Git, you have all the commands starting with Git, right? Git sim space ls git init. So likewise, here all the commands starts with Docker. So there are two components on your machine. One is the client one, which will receive these commands and it will talk to the engine, which is a daemon program, and it will serve the request. So if you install Docker, so if you run this Docker version, you'll be knowing a lot of details. So it says that this is developed in Go language. So Go language, I might be knowing that it is developed by Google. So it uses that Go language stuff, and then you will also be seeing two editions. One is client version and as well as the client API version, etc. here. So Docker space version will give this output to you, screenshot. So here, Docker containers and images you discuss. So all these images are read only. Yeah, this is we have just now learned, and as it is built by either you or some Docker users stored in the hub or your local repository. Now, what is containers? They are isolated app platform which contains everything which is needed to run your application. Basically, the run format of images. So the containers can spin up using one or more images. So in the hub, Docker hub, vendors maintains their own different repositories. For example, Ubuntu, they have their own repository where they have multiple versions of images of Ubuntu there, OS. And similarly, Red Hat. Similarly, not only OS I'm talking about. Similarly, let's say that Nginx, a web service. So they'll be having their own images of different versions, or Apache, or MySQL, Java, you name it. So all those softwares will be available in the form of those images. Public one, like your GitHub only. Everyone can download a lot of images available. There's no limit, like large number of images are available for your usage. And to download this image, to spin up the container, to maintain this stuff. So there are some orchestration tools available. Majorly Docker comes with 3 tools. One is Docker Machine, Docker Swarm, Docker Compose. So the Docker Machine is used to provision Docker on multiple hardware machines or virtual machines, VM machines, or EC2 machines. So that means that let's say you have 3-4 EC2 or VM or hardware physical machine, you can install Docker machine to maintain the images running and the containers running in all the machine from a single unit. So Docker Swarm will help you to cluster all these engines running on the different machine so that you can scale the containers in case if there is the usage increases. You can scale down, scale up based on the user base. So if you look at the Docker Compose, what is exactly this one? The Docker Compose one is a multi-container application platform. What it means is that you can spin up multiple containers on a single machine using Docker Compose. So what do you mean? What do you mean? Like, for example, I would like to deploy a web, an application container. I would like to deploy a DB container. So all this stuff can be done using a single Docker Compose tool. Now, what are the benefits of this? One, I'm talking about benefits of Docker. By this time, we should know what we are talking about. One is we now no need to worry about compatibility issues, whether we have all the prerequisites. We can focus on the development of the product or the application. So sysadmin activities also now will be reduced. Faster development cycle can happen, and portability will be there. So you can build in one environment and you can ship to another environment without any all these prerequisites checking or etc. Because when you ship it, you're shipping the entire stuff. Scalability is there. So you can spin up any number of containers based on the need. You can run more applications on the host machines because of the less resources required by those each guest instances, or we call it as like containers. Before we are doing the images, I think let's just spin up an EC2 machine and then install Docker in that. So let me log into my console. So I'm using one of the existing machine. Trying to stop processes which were running. I'm just checking whether we have this Docker available in the repositories. Yeah, it is available. I can simply install Docker from here. I'm install -y Docker. So now service Docker space start. So you could see that now the process is running or it's running, the daemon is running. So which version it is? Docker space version. So when I use this Docker space version, it displayed two editions. One is client one and it is server one. The client version is this one, 2010.4. And the API version is this one, the Go language is this one, etc. Of course, I think the server engine is also same stuff. API version is this, etc. And yeah, this is open source, right? So the Git commit and all those, the exact code is also it is displaying. And experimental tool means it can be used for production grade installation as well, because in case like if you want to do some experiments, yes, you can go ahead and do that. But developed using Go language 15.8 edition. So it is mentioned over here. The Docker space hyphen version will give a short form of that. Docker version is this, build is this. Again, this is the Git code, Git external code. If I use Docker space images, I don't have any images in my local repo, so that is the reason it is returned 0 output, empty. So let me pull one test image. Docker pull hello -wall. So from where it is pulling? From the Docker hub. So yeah, that is then the code of the image and status downloaded the image called hello world. What is this latest is? Latest is a tag of that image, so that the image can have multiple versions. Because we have not suffixed any tag while pulling the image, it downloaded the latest image.
Raghu, here, why didn't it ask for Docker Hub credentials? Have you logged in before?
No, I never logged in.
Then it should ask for Docker Hub credentials, right? While pulling.
No, see, if you look at the Git, right? Git is what public repository. So while checkout, you don't need any credentials, but while check-in, you need to supply credentials. Here also,
Okay.
if I want to store an image to Docker Hub to my account or some account, then it will ask credentials.
From your local.
From your local.
Okay.
For pulling, it not.
Okay. Thank you.
Yeah. So this is the public policy. Any you take any services, same thing. Now Docker space images. So we pulled one test image now. So it is having this name called hello world latest. This is a unique ID, image ID. Even if you pull it also in your machine, this is ID, it will be displayed. When it was created 2 months ago, it looks like updated or created. The size is only 13 KB. I think this is having some 10 to 12 lines of welcome Docker message. That's it. But the text, I think, just image. That's fine. It will not contain any voice, I guess. It is not having any software. Nothing is there inside this particular image. So how do you execute the container? How do you basically run the container? Like in your Amazon, you are spinning up EC2 machine. No? So here we have a command called Docker space run and the image name or image ID, anything you can give. So when you do that, it actually spins up a container, executes the output on the screen, but you're not asking to hold anything, right? It's immediately it will go into shutdown mode. In Docker language, we call it as exit mode. So it will not be up and running. So why? Because I am using this command called Docker space run space hello -world. So I'm saying just run it. That's it. It's just running the program. As simple as that. Yeah. So it is an allow from Docker. This measures so that your installation appears to be working correctly, etc., etc. Now there is a command called docker ps to list running containers. Definitely, obviously, it will show empty results because I told you just now the container which just now we spinned up when it exit mode to list all the containers which are also running, and then in exit mode you use this -s switch. So here we can see that the container in exit mode. So this was the container ID. This was the image it was used to spin up the container, and this was the program ran inside this particular container when it was executed, and when was exactly you spin up that particular container. Current status, and also because we have not given any name to the container, randomly it given one scientist name. So this is why, because you should know little background about this. So Solomon Hikes, yeah, might be knowing this person name. So he is the founder of Docker. Young guy, not I think he's, I don't know how old he is. I think 30, 35, 36, 36, 38, yeah. So he's a currently CTO and chief architect of Docker, and he is the creator of this Docker open source initiative. Okay, so his current job is to build the platform for developers and sysadmin to build ships and etc. That is the little background about this Solomon Axe. So this guy, I'm not sure, I think this guy might be from science background. So that is the reason probably he would have developed this program providing science on scientist name. So whenever you spin up a container, if you don't give a name, you will see one scientist name randomly assigned to that name. Right now, I don't need this container. Why it is still there in my memory? Can I remove this container? Yes, it's just like just removing your EC2. Your image will still be there. So how do you remove? Docker space rm. I can give the name of the container, or I can give the container ID. Both can be given. This is container ID. Or I just can also give first 3 letters of the container ID. Anything is fine. So it will remove the container. So you cannot remove a container if it is running. You can only remove a container if it is in exit mode. Okay, got it. I got some idea about this thing. So how many containers I can spin it up using one image? N number of, like in your Amazon cloud, using one EMI, you can spin up any number of EC2 machines. Similarly, you can do the same thing with this also. So now let's talk about a little bit about Docker Hub. So here we'll just now discussing, it is a public repository where you'll find lots of images available for your usage. They are available in different repositories. So you go to Docker Hub, create an account and log in. So, and then you can search for it. So let's go to the Docker Hub. If you don't have an account, just create one account right away. hub.docker.com. Sign in. So Docker ID here, I can use it. That's what it's like. I think I created this when Docker actually released in 2014, I guess. Same year, I think I've created this thing. It's one of the oldest account in case if they are searching the oldest user IDs which are still active. So when I log into this Docker, it is like a GitHub one. So you can find out a lot of images. I mean, this is my repository. So because I generally use this for my training purposes. So you could see a lot of images uploaded as part of this stuff, etc. So you can also create your own repository. So if I go ahead and create a repository, it'll ask me two types of repository similar to your GitHub. One is public and one is private. I just now telling you, right? So if I create public repository, or anyone can download those images using my repository name. Yeah, so in case if I use private, yeah, definitely it is not visible. In Git, it is not free private creation, so it is some premium is there every month you have to pay. Here also in Docker Hub, I guess private is restricted. So that's you could see right, and that option is not at all working. So there is only one repository you can create, it seems, which I think I already created, etc. Now, so later Docker also introduced a service called auto build trigger, so that you can build, so integrate with Git and all the stuff. So I think that is also possible. So you can integrate directly with Git, and as soon as the what you call developer check in the code, like you're doing your Jenkins, right? So you can do that, and then your image can be ready. So for example, so you can link with any of these things. We'll do that later. So was it this possible? Yeah, but right now I'm not using anything as of now. We'll talk about later that. I'll come back to my repository. Yes. So this is my repository. I only have one repository under my account. Or I can create any number of repositories. Public, it is free anyway. This thing. They also introduced later organization. That now let's say that we're all team. So I can create an organization. So so there are for companies, this is chargeable, I think this much, or if it is free team, unlimited public repository, one team with 3 team member up to 3, you can go ahead and create one public repository. So for example, I can create a organization DevOps. Mine is DevOps. It's already there. It's okay. I'll say that DevOps. Okay, let me do one thing. Let me DevOps. That's fine. I'll leave it here. 05. And it is there. So then I can invite some team members. So I can add member if we are here in a, so we can all together collaboratively work on this stuff. So this was, I think, 3-4 years back, they've introduced thing, having a repository, and you can monitor activity and all that seems. At any point of time, you can look at the settings. Yeah, maybe this is free one. So people can share the images, etc. here. So coming to the images. So for example, if I'm looking for Tomcat, I can look for some Tomcat images. So this is official Tomcat with logo. So when I click on this thing, yeah, so this is from the Tomcat repository, official images can download. And this is about the description of this image. So the maintenance, what they were doing, the reviews, how many versions we have, tags. So this is JDK 11 supported, 8 supported. So you can also look for one Tomcat where we have some sample applications, yeah, and all this stuff. So this is all about description. This platform independent can be used in all these flavors of Linux or OSs, etc. So if I want, let's say I want like a MySQL image, can I get search for it? Yes, this is an official MySQL image. So like as if you look at here, hundreds and thousands of images available. Some of them are so contributed by some XYZ, and then you can also search based on the databases. Yeah, so based on the monitoring tools, if I'm looking for some monitoring tools software, if it is available, it will be listed here, etc. And can I also download, let's say, some commercial softwares, commercial images, let's say WebLogic, which is from Oracle. So this is from Oracle. So they also hosted here, but you cannot download that at free of cost. So you could see how to go for press, check out, and you have to buy this image because WebLogic is a licensed one, right? It's a Fusion middleware. That is the reason I'm talking about. So similarly, you can search for any such kind of images, and then you can download that stuff. The total how many images are there? I think as of now, this number of images are there. This big, so very difficult. 74 lakhs means that is. So you can also go for official images, or you can go for verified publishers. What is verified publisher is means it is not an official image, but let's say App Dynamics is from App Dynamics. Docker just verified it, but no, it is. We really don't know that whether it is official image or not. That's what it means to the meaning of that. And these are some of the plugins so that you can have some API to talk to the Docker environment from your platform. Yeah, so it could be a VM platform, or it could be any other platform. A lot of plugins are available, so which you can use it, and then you can start logging into this platform, network, volume, etc. Many things are there. What is this Docker? So this is containers where plugins you have seen, right? This is like Docker engine for communities. So if you want to download any those programs in the form of containers or images, you can go. This is an official different OSs. So anyway, we'll talk about more about that later. So I'm coming to my repository. This is like my repository, wherein I can find a lot of images here. And yeah, one repository, mostly people generally use like library. So there's one Docker official repository. There will a lot of examples will be available. First looking for the Docker one. Yeah, I think this one, I guess, I'm not sure, but yeah, we'll come to this point. So where you can find out some sample images for your project purpose, POC purposes, etc. So we talked about this tag. So if you don't mention any tag, when you'll get the latest one, and if you mention a tag, you will get that respective image. So now, what if I run a command like this thing without having a local image in my local box? So what it will do, because it is not there in the local repository, you don't need to pull it again. It will pull and run the container. So in this case, Docker run Ubuntu. This time, this is the OS, Ubuntu OS. So version, this one is a version because you're mentioning the tag. Once you download it, please run this command inside the container of the Ubuntu. So that is, you can also suffix a command to run inside the container. So in the second one, like Docker and Ubuntu, this time we are not using any tag. So again, it will download one more latest image and run this particular command called PSI P6 inside the container. So Docker run Ubuntu PSX, listing the process basically. So it is not there, it is trying to pull. And then it ran that command called process list inside the container, and then it returned the terminal back to my EC2 machine. But what happened to my container? Yeah, we just now learned, right? It will go into stop mode. Fine. What about images? The images will be there. This time the image size is around close to 72 MB. So is it Ubuntu only 72 MB? No. It only contains the minimal OS packages required to run any Ubuntu stuff. It will not contain the entire OS. So now, fine. So this is the command it ran inside the container. The current status is run. It's stopped. Okay. So can I start this container? So try this Docker space start. Give the container ID. This time when I don't want to spin up another container, I want to start the existing container because it went into stop mode, right? Check it out. No, it is not running. So a container will run as long as Docker run command is executed. So then fine, then why I don't need this container. So let me remove this. So my list is empty. Container list. So this time, what I would like to log into the container because you said it is a kind of guest instance, VM instance. I use a switch call -i-t. So what it will do is it will interact with the container. -i stand for standard input, -t for pseudo terminal. So now what is this one? Because I am actually trying to log into the container, I don't know whether we have a shell program there or not running inside the container. So, right, shell is an interface between user and the kernel, wherein you execute all the programs commands, ls, all these commands. So I'm trying to start a shell and log in there. So bin bash is the shell I'm trying to log in. So Docker run -it Ubuntu space bin bash. I'm inside the container. Now this is where what is the host name of this container? Some name. We remember the container ID. It's the same stuff. Right. Now what is the IP address of this? If config command, that command is not there inside the OS. That is the reason it is not running. We just now discussed, no? So it contains the minimal OS stuff to run the container. So no guarantee that you'll get all the commands working here. Now, can I create a user? Yeah, user is created. So is it there? Yes, it is there. Fine. How do you come out of the container? So I can use exit. But when I do exit, what will happen? The container will stop. This is like shut down. So Docker space ps-a, if I do, status is, it went into stop mode. So now what then? How can I log in? Yeah, it has to be in start mode. But this time, can I start this container? So let's try. Docker start 964. Let's check it out. Docker PS. Yeah, this time it is running. Why? Because a bin bash program, a program is running inside the container. So whenever, if any program is running, it will, you can start the container. So it will hang because there's a process inside that running. So now, fine. I want to go back to the container now. I mean, basically, I would like to log into the container. So can I use Docker and -it? No. Why? Because if I use Docker and -it, it will spin up a new container. But I don't want to spin up a new container, but I would like to get into this running container. So you can use Docker space attach the container ID 964. So I created a user, right? I just want to see whether it is still there or not. Yes, it's still there. Okay, so how can I come out of the container without shutting down? Yeah, so what you can do, basically, you can use this shortcut, Control plus P plus Q. So this time, if I do Docker PS, the container is still running there. So again, you can use Docker test to go back to the container, etc. Fine. We'll discuss more about that. But -it is what I said we are trying to discuss here. So we need to understand the container processes. I have told you already, a container only runs as long as the process from your specified Docker run command is running. So in our case, Docker bin bash was running, right? So because it was triggered using Docker run, so when I started, it was running. But when I do exit the bin bash program, and I was trying to come out of that. As soon as I said exit, because bin bash was down, the Docker container went down. So your commands process is always process ID 1 inside the container. So when you use that, Docker, and basically it is like init kind of stuff inside the container. So that's ID is always process 1. So that's the reason when I download that image, Ubuntu, remember I used ps-ax. So it was telling me that there is only one process running, ps-ax. That process ID was 1. Yeah, so this we just now discussed. So this is run-it to interact with the container. This is Control plus P plus Q to toggle between container and your host machine. How much memory a container can take? Because we did not configure any limit, it can take maximum CPU memory available inside your machine. So if you come to your machine, your host machine, yes, or like if you stop command, so there are a lot of processors running, right? Yeah. So out of all this processor, we want to filter it out a Docker process. So this is just one process for me. So how much memory this can take? Like any other process, the maximum CPU memory available inside my machine, it can occupy, because we have not limited anything. So for me, it is just a process. For me means for my EC2 machine. I don't know what is instances, container, etc. here. So if I use Docker PS, we have a container running. Yeah. So so that is also a process for me inside the whatever the Docker engine here. So it could be a child process of that. It could be anything. So if you try to do grep bash, So probably like, a process might be related to that. So I not bothered about that. It is all child process of the engine. If engine is down, yeah, of course. So all your the containers engine things also will be down. So we have seen this container ID there using Docker PS command, but that is a short ID. If you want more details of the container for troubleshooting purpose, etc., you use Docker inspect. In this case, Docker inspect space the container. I use the star. Yeah, so a JSON format output will be displayed of this container. So from here, it started. So this is actually the long ID. This is actually short ID. So when it was created, what is the path? What is the status of this? Okay, what is the image, host name, and where is exactly the log path on your EC2 machine? This is the log path. So I mean, for troubleshooting purpose, you can visit this. And port memory utilization, how much CPU it is utilized, and then etc. etc. Also, you will see name of the container here, and is there any data volume mounted, those details, and then network settings here. So you could see this is actually network settings. So default network ID of a container, the series starts with 172.17 in Docker. This is given by Docker. So it also having a gateway, okay, and IP address, etc. And then MAC also there. And if I want to filter it out, just I need IP address. Yeah, what I can do, I can search for it. Grep IP address. And only IP address will be displayed. So 2 is IP. So if I spin up one more container, I'll get 3. So 172.17.0.3 will be the IP address. So long ID inspection and everything. If you want to know, you can use Docker inspect container ID. Very popular generally for troubleshooting purpose. Yeah, we just now discussed -A list all your containers that are stopped also. Okay, -IT is good. I mean, which can help me to interact with the container, but from the container in the detached mode. So that means the background mode as a daemon. You use this option called -D. So Docker run -D. This command, this what it will do? It will create a CentOS container. Inside this CentOS container, it will ping this command IP address, ping this IP address for close to 50 times. So my container will be running until it not finish this particular task. So as soon as this task is completed, container will be done. I mean, it will stop. So, but if I run this command, you will not see anything output on your EC2 machine. So you will get a container ID, and you can use Docker logs container ID to tail what is happening with the container, tail the logs. Fine. Okay, let me try this option now. So Docker run -D CentOS edition 7 we are trying to download, and ping 127.0.0.1 -C 30 times. First of all, CentOS is not there in my local repo. It is downloading, spinning the container, and it will return the terminal back to EC2. But if I use Docker PS, it will be running in the memory. So I want to log it. Docker logs tail. I haven't followed. So if I do this thing, then you'll see the output. The container is still there, and inside this container, this is happening. That 20, 26, 30 times we asked to be there. Until it did not finish, the container also will be there. Now, once the task is done, Now check it out whether the container is still there or not. It is not there. Where it went in the stop. Okay, but I could see one container still running, that Ubuntu one. Can I remove this thing? No, it will not allow you to. Why? Because it is up and running. So you need to stop this thing. Or is there any other way? Yeah, you can use forceful -f also there. So first of all, here I'm trying to stop it. Now I want to remove all the containers. So yeah, do I need to give a single command line by line, or you can give space, docker rm space container ID, space container ID. That is also possible. Or you can do this command vs -a -q will give the container ID. So you can supply this as a parameter to rm command. So because they're already in stop mode, it will remove all the containers. So that is also possible. So what about images? Yeah, images are there. Now, if a container is running, and if I want to remove the images which is used by the container, you will be not able to do that. So first of all, you need to stop the container, remove the container, and then only you are eligible to remove the images. So intentionally they restricted that. How do you remove an image? RM is for container. This is for RMI. Hello-world. So the image name done. So it got deleted. But what is untagged? Basically, the hello world is a tag to the original reference ID, whatever that, D1111 in the memory. So it is a synonym, soft link kind of stuff. First of all, it untagged the hello world and tagged this particular 512, etc. And then finally deleted these things. So this will be useful, for example, using, if I have an image, can I create one duplicate of image? Yeah, you can tag. So when you use tag like in a soft link, you get one more image. But when you really try to delete the original image, because it's already tagged with another name, it will simply say untagged, but it will not be deleted unless you delete the last image which is tagged with the original number. So let's get into some practicals now, the container practicals. So I would like to run some web application inside a container. So here the Tomcat is a server I would like to run, but I would like to access it from outside. Outside in the sense my browser, that because inside the container it will be running. Now the problem is container is having its own IP address. It's not a public IP, by the way, and I have an easy to machine having public IP. So what I can do is I can map my public IP port to the process running inside the container using capital P. So when I use docker run -d capital P, so it automatically will refer which process running and which port inside that, and it will try to randomly map one port from our public IPs, which is available, to the process inside that. So here in this case, Tomcat is running on 8080, right? It will try to map. The range it will give me is that some, I think 32,000, some 670 range. I think some 10,000 ports are there. It will give that range, but randomly it will give one port to the running the product system. Right. So if you download the Tomcat original, right, you don't have sample application. So what I'll do, I'll get it one which from my repository. So let me just check it out whether I have Tomcat or not. Yeah, on Tomcat, let me download this one. So docker run -d port map capital P. So this is my repository. Tomcat. Am I having any tag for this? Tags. No, there is no tag. So I think I can directly download. I think 7 is there. Let me try. Tag. 7. It's downloaded now. So if I use Docker space images, you could see this is the one. The name here appearing that after my repository name. So why? Because it is actually downloaded from that repository. So it will download the that stuff. So tomorrow, if I want to push anything to the repository, I have to tag that particular name with the repository name. And then I can push. Of course, you need credentials, login credentials. Otherwise, you cannot push. So now my purpose is Docker run -d capital B. Okay, it's already there. It's pinned up, right? Okay, take it up. Docker PS. Yeah, it is. No, the container is running. This is a container ID. This was the image it was used. And in the ports, yeah, you could see, right? Randomly, it given one port. The range is from 49,000, it seems. Okay. Because we are not given any name again still, it given one randomly one scientist name. Now, what is 8080? Inside that container, because Tomcat is running 8080, it referred that particular stuff. And then automatically it mapped there. So, of course, I don't have any readme yet, but generally it is good habit that you go to the readme stuff, right? Then you'll be knowing that. So yeah, so this is collaborators. Okay, we don't have any webbook settings and anything. Right, generally Docker file kind of stuff details will be there, wherein you have all this detailed stuff. Fine. Now, how do you access from outside? So I know that the port number is 49,153. I open all ports anyway, right, in my machine. So I'll go to 49,153. Yeah, see, I can access my Tomcat. I'm not install anything, right? It is easy. / images. Oh, sorry, what is it? Web apps. Not the web apps. Okay, examples. Yeah, examples is there. And then I think sample is also there. The sample is not there. It is mapped to the port 49,153. This is your EC2 public IP machine. Basically, what it has done, it is, for example, if this is your EC2 machine, and this is your container, and this is where that Tomcat is running here on 8080. So my Docker P command will basically map to this particular process here, and this is where it given one number. What is the number? 49,153. And now from my laptop, yeah, so I can access by my browser. This stuff using this IP. So anyway, I have public IP, right? Using my public IP. So this port number I have used, which actually in turn talk to the container. Any questions on this? Or let's clear this diagram. I think all of you already working on Docker containers, I guess, right? Looks like there's no questions from anyone.
Raghu, that 49153 port, I'm not able to access it, though the port is, listening.
No, that is my port, my EC2 port, right?
Not yours, mine. I answer, I mean.
What's okay? So you're trying to access my IP.
No, mine only. So
Okay,
where
Okay.
I ran the Tomcat, everything is fine. Only thing is I cannot access it from browser.
That's it. So Docker PS, is it listing that port mapping is done?
Yeah, it's there. I could see it. It's mapping to 8080 TCP.
I see. Okay, then I think it should work. So 1 second, give me private IP of your machine.
Sure. I'm pinging on the chat. Where is this? Second. I'm not seeing the chat window.
Yeah, there's next to participants.
Oh, yeah.
Okay, this is a public IP, right?
Yeah. Yeah.
Okay, that's fine. Let me try. I thought like I'll try with private IP.
All right.
Well, okay, this. Which image you have used? Mine or the DevOps image or any other image you have used?
Okay. That I use Tomcat from library.
That is not having that sample applications.
Okay.
So use mine. What was mine?
Okay, got it.
This
So
one.
basically, your image is modified from the library Tomcat one.
Yeah, I written my own Docker file and all that stuff.
Okay, fine.
I'll give you that.
Okay, understood. Thank you.
So we used capital P to do that. So if you really don't know in which port it is listening, and if the image is from some XYZ sources, yeah, I can use capital P because my Docker, a command will automatically scan, and then it will be knowing, what is the program running and at which port it is running and all the stuff, and then automatically it will map it to another dynamic port. Okay, these are some of the references. What's next? We have some good time. I think we can start it. Yeah. So we'll now try to discuss about building images, Docker file, understanding those Docker files, managing those images, volumes, and then we'll try to talk about pushing those images to Docker Hub, and then we'll try to talk about some of the basic container networking, and then CA process inside that. So far what we have learned, we learned about benefits of container-based virtualizations. We have learned about some of the Docker concepts, terminology, and then we did one simple container example, right? Couple of container examples, And these are the commands we just ran. One is docker run, docker ps, docker images. Yeah. So these are the commands that we ran here right now. So yeah, anyway, this is the agenda. So we'll see how much we can cover today. So we'll try to talk about building images, and we'll try to introduce ourselves to a Docker file, and then try to manage those images and containers, distribute those images to the hub. Volumes we'll try to discuss, and then basic container network we'll try to discuss, and then Docker in the CI process, continuous integration. So let's start with the basic images here. Now, we need to understand the image layers, architectures. Here, any image that you try to download, you actually nothing but trying to download multiple layers, because one image or images are comprised of multiple layers. So this is our kernel, our host machine. So when you download an image, let's say this is, I guess, some Debian based image. So the layers will be like, looks like a nice cake, right? So you have this base image here, Debian base image. Probably the minimal OS which is required to run basic operations, so it will be there inside this particular layer. On top of that is some Emacs, I guess it's the editor. It is there. On top of that, you have this Apache is there, etc. So these are all layers, 3 layers are there. So it always refers the parent image and then parent image whenever you execute some commands here. Now, when you spin up a container, it actually forms one writable layer on top of this container. It is looking like one swimming pool on your apartment, right? So this is the very transparent layer, writable layer. So any operations you do inside the container, it will be inside this transparent layer, writable container layer. Now, when I exit or when I shut down this container, this layer will be discarded. Yeah, so all the work, whatever we do inside the container will be deleted, or it will be lost. Why? Because all these images are read-only images. So here you cannot save anything to this image at any cost. You can't do anything to all these images. So again, these images are again what? Another layer. So this probably might have developed by Debian. This is probably from the Emacs editors. This is from probably an Apache stuff. So when you install, basically, it is actually found the kind of one layer in this. So this is now one image here. So we need to remember always one thing, that every image contains a base layer, and the Docker uses this a system called what? Copy on write system. Yeah, so the copy on write, so that it reference parent images in this case. Fine, we got some idea about images. Now let's talk about this writable layer, container writable layer. So we just now mentioned Docker creates a writable top layer here. Look like when this is how when you spin up a container. All your parents images anyway are read only. So you cannot do any changes to here. It's only whatever you do, you will be doing only in the container. Now, if I want to build my own image, my company image, what I'll try to do is that I'll spin up a container. I'll log in there. I'll do whatever I'd like to do. Let's say install some software, copy some softwares there, etc. Now, I cannot, save this back to the image. So I will save it as a separate image using Docker commit. So what it will do, it will save all the changes in that container layer, which was formed, and all the work, whatever there is, that you can save by giving one name. So the syntax is Docker space commit, save space the container ID space any name you want to give. See, in this case, like you're given the repository name or username and app name, but any name you can give me. So let's try that one option. So I would like to log in to a CentOS layer. CentOS layer. I'm inside this. So I'm having VA editor inside. VA is not good. So let me install VA, a small software editor. So it is installed. Now check it out. Yes, still not there. It is there now. Test. So they got installed. So now I'm coming out of this container. Fine, it is in certain mode. Still, I can save as an image. So what I'll do, this is my image container ID 920, right? Just to avoid confusion, I'll do one thing. I'll stop this. This is the Tomcat one, right? I can use icon also. So I have only now one stopped container. So this I'll use Docker commit. This is my container ID space. I'll give a name. Okay, what is that? Because I installed VA, I'll put VA on CentOS. I'll give a number called 7.1. That Docker space images. So you got a new image. Now what is the size of this one? This is having 321 MB. But when actually when I downloaded, it was 200 MB. Okay, so now I installed some software now, that VA and all this stuff. So inside that, it occupied this much space, even though it is not 100 MB, but yeah, it actually took that particular stuff. But in the background, again, Docker actually will not use 321 MB. It is actually referring to the snapshot called 200 MB. Only that incremental thing will be there. 121 MB only will be there. Okay, so just to save the memory, storage memory. Now, what if I try to delete this parent image CentOS? Let me try to delete it now. We just now learned that it is a reference to that snapshot. That means like, so if I lost parent image, and then my VA image, will be having trouble, right? So what is the internet? Okay, okay, I think some container is using. Fine. Okay, let me first of all remove the container. We already save this work as an image, right? We remove that. Now, if I try to use RMI, you can see you just actually seeing that only untagged, but you did not get the message called deleted. Why? Because it is referred by this VA, the original image CentOS, even though it is not there, it will be there in the background. So that still that it is because it is referred by this particular image here. So that's the reason that deleted stuff did not came. Now if I delete this one, Docker RMI VI CentOS 7.1. So now I got the deleted message, because now at that particular snapshot is not referred by any other images. So I don't no longer needed this in snapshot. So it now deleted. Exercise on this thing. Now we'll just start this thing, and then we can wait for today. Now Docker file. So it is actually basically a concept or a configuration file from Docker. So in the book definition is a Docker file is a configuration file which contains some instructions for building our own Docker image. Now, Docker commit also we have seen, right? Now, what is this difference? So Docker commit is not an effective way. You take image, spin up a container, install some softwares, and then use Docker commit to save an image. It's not effective, right? This process has to be automated. So this process has to be automated. The Docker file will do that stuff. So you can write some file to 1, 2, 3, 4 instructions in a single file called Docker file. When you run that file, that's it. So it will pull the image, it will spin up a container, it will install the softwares, and then it will save that as a commit it as a image, and then we'll delete the container, and then that's it. So all that in a sequential steps, you can put it in a configuration file. Now it's an effective way. Why? Because when you try to integrate with the Jenkins kind of stuff, CI process, so you'll be creating artifacts. No, in those cases, it will be easy for you when you, let's say, you want to put the war file in a Tomcat, etc. Docker file will be more useful. Let's check it out one sample example. So basically, here the major instructions it will be what to do when a building image is what I said at the beginning. One is from instruction. This is the instruction which specifies what is the base image you should use, and then followed by a run instruction. Now this is the command which should be running once a container is running using this particular base image. So here in this case, take an Ubuntu machine, install some 1, 2 softwares, and then spin up, commit an image. So we'll write one Docker file. Case instance, so VA Docker file, initial cap from CentOS. I'm using CentOS, and then here yum install -y VA we install it, and then I want to install HTTPD also, web service also install. That's it. So we'll save this file for now. Now, how do you build the image using this thing? I can't use Docker commit. I'll use Docker build. Okay, I would like to tag with a name called http:/CentOS 7.2 something like that space. Now where is my that file? The source. Currently it is in the current directory, no? So I'll use dot. Or if it is in a separate folder, I'll use the absolute bar. So I'll say that first it is taking CentOS and then pulling. Because CentOS we just now deleted, no? So it is pulling actually. And downloaded, running the second command, installing a VA software. Okay, and then third command, installing some HTTPD software. Completed. Removing intermediate container. Yeah, see that intermediate container actually the background it's pinned up, and that is now not needed. No, so it removed, and it successfully built the image, and it tagged it. Check it out, the Docker space images. So where is that? This is my image. Now this is more effective, right? Comparatively with your Docker command. So what else there in the Docker file? Yeah, Docker file is a very big concept. Yeah, we just only learn about from and run instructions. So the commands which we use in run instructions are specific to the OS. In the slide here, it is because it is Ubuntu apt-get it is used. If it is CentOS and Red Hat Playbook, we will use yum. So run instructions also can be used to install multiple softwares. In this case, if you want, you can aggregate multiple run instruction using ampersand symbol, www. So run apt-get update and all this thing. In the background, this run section, what it will do, it will actually on the top row writable layer, once the container is spinned up, no, it will perform all those operations at the top writable layer, and then finally it will commit those changes to the image. I can also use line breaker here. I can use this line breaker to install multiple softwares. Yeah, and then I can do many things here. So this is a command we have used, docker build -t and the image or the tag name and the path. Let's, if it is in a let's say my project folder, you just give the folder name. Yeah. So you can, because Docker file is case sensitive, no, initial capped. Yeah? So you cannot have multiple files in the same folder. So you have to have separate folder, separate Docker file. So apart from and run, we also have CMD instruction.
Your voice was breaking.
Oh, is it? Okay. Is it now or like when was it? Hello?
We
Can you
can
hear
hear you properly, Raghu.
Yeah, last 2 minutes we can't hear. It was breaking.
So okay. So someone saying that. So you can hear, right? Somebody is saying that. You can
Yes,
hear.
we can hear.
Okay. Okay. So who is having
Yeah.
problem?
Okay. Yeah, one is my side only, I think so.
Okay. Yeah, just check it out. So we have seen from and run instructions. So there is one more instruction, CMD. So this is a very popular one. What is this will do? When you spin up a container, what is the program you want to run inside the container? So that you can mention using this CMD. So for example, I install HTTPD software just now, right? Now I want to start the software HTTPD. So then I cannot use run. Run is for only installing that, executing those commands. No, I want to start a software. Then I'll use CMD. So you need to remember that CMD has no role while building an image. It is comes into action only when you spin up a container using that image. Okay. So there are two formats where CMD can be specified. One is shell format, wherein you don't need to follow any what do you call square brackets, double quotes, etc. And the other one is execution format. And we need to remember one thing: CMD can be specified only once inside the Docker file, mostly at the bottom of the file. You cannot mention CMD multiple times. And in case if I want to override, let's say some arguments I'm passing, I want to override those arguments. Yes, you can do that during runtime. So let's do one example. In this case, the same file. What I'll do, I will run this CMD, ping some, what do you call, type paper 10 times like that, and I will try to use a Docker file. Now, the same Docker file, I am adding this time. CMD. I'm using execution format, it's preferable actually. Ping, put a comma, space, and so hyphen C, comma, what is syntax? Okay, it is giving first IP address and then like, so 127.0.0.1 30 times. Just checking the syntax if I'm missing anything or not. Come on. Okay. So now, because you've done some changes to the Docker file, again, you need to restore the image with these changes. No, that's fine. I can override that image using the same name, so it will override the image. Docker build -t and same name and dot. It overwritten. It took like milliseconds. Why? Because everything is already there. It is just adding one extra line. No? So it's meant of a container added this thing and then that's it. But we learned, right? CMD has no role while building images. Like it will not do anything else. It's just adding an extra entry there. Now, what I'll do, I'll run this images. The Docker run. Because in the CMD is there, I'll do one thing. Okay, let it be. Run. I'll not use -d. I'll use directly this name. Let's see what will happen. So, because the CMD is now came into existence, came into perform some action, it started pinging this IP address for those number of times which was mentioned in the Docker file. That's it. That's Docker PS. Yeah, I don't see any container because it would have been went into stop mode. So if you want, I can remove safely the container. My CMD is very useful. Let's say if you install some company software, I want to run this software. Whenever I spin up a container, I'll be using this stuff. So yeah, we'll stop with this slide. Now CMD actually, it will not allow you to supply any parameters during runtime. So if I want to supply some parameters for that, then I will use this entry point. So what it will do, it will execute as a shell and this thing, but it will accept some arguments here. Yeah, but again, you have to use execution format, shell format. Even though it works, it will not accept arguments. Yeah. So in this case, our container is running like an executable file or something like that, which accepts arguments. So let me do one thing. Let me first of all edit the Docker file, and then I will change this CMD or remove that stuff, and then I'll add this entry point and build a new file. And then we will now see when we experiment with that. So we are in Docker file. Can I comment this? Yeah, you can also put some comments also. And entry point. So what is that? Same thing, right? I think format is same. Because you've done some changes to the Docker file, you build it again. That's built in. Now this time I'm running that stuff. It is up to ping, it is there inside that entry point. So what I'm doing now, I'm supplying some parameters. So hyphen, or like in this time, I'll use google.com. Please ping this thing for 10 times. It is now pinging Google. I can supply as a variable. Instead of Google, I can put Microsoft.com or Yahoo.com. Yeah, anyway, up to ping it is there now. So from there, it will right now accept that particular remaining things as an argument. Right. So with this, we'll stop at this moment for today. Yes, any questions from anyone?
if we have more commands to give, then how we can give that?
You mean to say
Like,
more
yes,
programs to run?
Commands, yeah. Like we have given ping and other commands also if I want to give them.
So because
Using entry point?
no, entry point also same, like only one you can supply. Now, but let's say that you have more programs or more commands to run. So what you do, you put one everything in one single file, .sh file. I'm just giving you an example. And then while building image, you can actually copy this file from your local machine to the Docker image, and you use CMD file to run that particular SS file, which contains all the instructions to run multiple programs.
Okay, so from Docker file, we'll call that SH file, which will be inside that same port.
Correct, inside the image. So
Okay.
how do you copy the SSH file to this thing? That you can use this, let's say in Docker file. So let's say in the current directory, you have this file called start.sh. So inside this Docker file, while building, what you can do, you can simply say copy. It will refer the current directory. So start.sh to a location where inside the container. So let's say you want to copy to some etc folder, something like that. You can just mention it, or you can put some dot. So now build a file. So when you build in the file, this file also will be copied to the image. Now go to this stuff and then put CMD, and then start the SH. That's it.
Okay.
Raghu, this way the file is going to be static with every Docker, right? So let's say if you want to supply some dynamic file, so one time we given one SH file, sometime we might need to give different one. So is that also possible?
Then again, you need to you have to use entry point, some dynamic variable. So environment variable you have to configure.
Okay.
So env you have to configure. Then that you can supply as arguments.
Okay. So files can be dynamic, right? It's not.
Yeah. Correct. Yeah. Okay. So any other questions? I mean, we have a lot of things in Docker file. So anyway, I will be discussing a few more options. But if you really want to check it out in a sample Docker file, a lot of examples are there. Even if you go to Docker Hub, right? So for example, I want to see what is the Docker file for Tomcat. So in real time, it will be very big. Some 100 lines will be there. Let me see if I can access this. Is the Docker file? Okay, I'm waiting here. Docker managing this Tomcat with this thing. So where is the template? Can I access this? We will look for edition 7. Let's set a file sample. Tomcat Docker file. I'm randomly checking. So okay, this is also very simple one, but yeah, you'll get a lot of examples. Yeah, so very lengthy files also will be there. So like this. So many options are there: work directory, run, expose, CMD. These are some of the examples. Some very good repositories are there wherein you can learn about Docker file and all this stuff. So you can refer any Docker file to develop your own this thing. Okay, I think this is one more for the smoke test after deploying Tomcat. Oh, this is a very big one. It's all like Go language, very simple, plain in English. So easily can go through this.
Yeah, hi Raghu. Can we store all the Docker images locally?
Yeah, that based on your availability as your resource space, you can store. Yeah. But in real time, we don't do, right? So company will be having their own DTR repositories. So DTR repository is like a private repository. So they can set up our own repository. So wherein we are supposed to store all images.
Okay. Thank you.
So if you want to have DTR repository, then your company has to buy license. That is not free of cost. Any other questions? So we'll stop at this moment. So I think, yeah, we'll catch up tomorrow then. We'll continue our discussion and Docker file.
Thanks, Raghu.